Konbanwa, everybody. That means good evening in Japanese. Today's lesson is going to be note sheet 11.6, area of circles, sectors, and segments created from those sectors. Let's recap. We need to know the area of a circle. Area of a circle formula is right here, pi r squared. Remember, units are squared, so the r was squared. Circumference is 2 pi r, or diameter times pi, which obviously diameter is 2 bar. Example number 1, we've done multiple times already. So let's just jump right into this one. We want to find the area of the shaded sector right there. What do we notice? M is the center of the circle. We know 9 is the radius, 120 is the central angle that it's using. So we take 120 over 360 times, we want area, so pi times 9 squared. Simplifying this, this is 1/3 times 9 squared is 81 pi. If 1/3 does not go into the 81, then we leave it over 3. But in this case, 1/3 goes into 81, giving you a final answer of 27 pi. And you have to put units squared. Hopefully you're okay with number 1. We've done that in chapter 9. We did it in chapter 10 quite a bit. And once again, we're going to be tested on it in 11 here. So by now, we're finalizing that you're able to do that. Number 2, take a look at the picture. What do you see? Insert idea here. Okay. What I notice, besides it's a funny looking picture, I notice that I see a triangle that is an equilateral triangle. So all sides are 12. And then I see this is part of a circle, this is part of a circle, this is part of a circle. And I know each one is 60 degrees. So basically, I see, if I put all those 60-degree pieces together, I see 1/2 of a circle. So we want the area of the shaded region, which is right here. So what are we able to do? We're able to find the area of the equilateral triangle. And do you remember the equilateral triangle formula? If not, pause it, look back. That's correct. The equilateral triangle is s squared root 3 over 4. So the side is 12. Plugging in the 12, what do we end up with? We get 12 squared root 3 over 4. That's 144 root 3 over 4. And that simplifies to 36 root 3. That units squared, that's for the equilateral triangle. The circle parts are not shaded. We discussed that 60, 60, and 60, so that's 180 of the circle out of 360 times pi times the radius. Well, we don't have the radius, but wait a second. These points right here are going to be in the middle, so each radius ends up being 6. So then we have 6 squared. This is 1/2 times 36 pi, which ends up being 18 pi units squared. Let's put it together. Remember, always big minus small. The triangle is bigger, minusing the circles. So our final answer is 36 root 3 minus 18 pi units squared. And yes, you will have to do something like that and leave your answer in terms like that on the upcoming test. Any questions? No? Let's proceed on then. Number 3. This is the segment chord part that I was talking about. So you want to find just this little piece right here. So this is going to be the challenging type question. So what we're going to do is we're going to star this one because I promise you it's going to be on the upcoming assessment that you will need to take, and it'll probably be one of those ones that decides between an A and a B or a B and a C and so on. So what we need to do is we're going to break it down into steps because we want to find this area. So the best thing to do is step 1 is to find the length of the radius. Okay. 2, what we're going to do is then we're going to find the area of the sector. What do I mean by the area of the sector? So if this is a radius and a radius, if I know this angle right here, I can find the area of the sector, this whole thing right there. Third, hopefully now you see a triangle. There's a triangle being created right there. So then we can find the area of the triangle. And then what are we going to do? We're going to subtract the area of the sector, the triangle from the area of the sector. Okay. Well, to be able to do that, let's look at this triangle first. So what we do know is that the 120 is the measure of the arc, so that's the central angle. The chord length is 12. Let's draw a line perpendicular across, breaking up this to 6 and 6. This 120 now broke up into 60 and 60. So we're looking at a little triangle off on the side here. So this will be step 1. There's a right angle there. All right. There's the 60-degree angle. The 6 is across from it. Right, we want the radius, so we know that this is the x root 3 side. So set 6 equal to x root 3. Solve it, divide by root 3. We get 6 root 3 over 3, which reduces to 2 root 3. That's the x side, but what do we want? We want the 90 side. We want this side right here. So that means that's the 2x side. So the radius ends up equaling 4 root 3. So step 1 is done. Part 2, now we find the area of the sector. Let me highlight that. So the area of the sector, this whole thing, including that triangle. Okay, well, we did that in example 1. So part 2, I'll put in green here. So part 2, what do? Find the area of the sector. That's the 120 over 360, right, times pi times the radius, which is 4 root 3 squared. All right. So what do we get? We get 1/3 times pi times squaring this. This is 16 times 3. 16 times 3, which ends up being the 48. So that worked out nicely. 1/3 of 48, that ends up being 16 pi units squared. And that is for the area of the sector, which is highlighted in the yellow. All right, the next step, we'll go to purple. So that's step 3, find the area of the triangle. So we have this triangle, okay? The area of the triangle is 1/2 base times height. All right, well, if we consider the 12 the base, we can figure out this side right here, which we have because it's the x side. So that's perfect. So we could have 1/2, the base was 12, the height has to be perpendicular to it, which is that side right there, 2 root 3. Multiply it all together, and you end up getting 12 root 3 units squared for the area of the triangle. Our whole goal, once again, was to get just this part right here. So what do? We take it, we got the area of the sector, which was 16 pi. We subtract the area of the triangle, and we have our final answer of 16 pi minus 12 root 3 units squared. If you need to, please rewatch it again, break it up into the steps. So every time, if you want to find the segment chord piece, you're going to find the area of a sector, and you're going to subtract the area of the triangle, and that gives you the little segment chord piece for it. For those of you that don't believe me that when we are working with circles, or recently I found out working with any type of area, I'm going to show you a short clip on using our special word for 100 in the workplace.
Square feet out there, 17, 18 hundo. Oh, I think it's 18 hundo.
So those of you that don't believe me, now you've learned of area. Now you could even do it in hundos. and such. Moving on to the last example, example number 4, we find the area of the shaded region, which is this area outside over here, which is made by, if you didn't notice, a tangent. All right, we're going to have to draw something in here. Best thing would probably be drawing in a radius, causing perpendicular here and a radius perpendicular here. What we do know is this arc is 120, so this angle is 120. I'm going to draw a line through there. So now I've just created two right triangles where this and this angle are both 60 because it was 120 to begin with, if you notice that. We want the area of outside here. So what we can do is, what I notice is, if we can find the area of this triangle, right, this area of this triangle, and then remove the area of this sector, then we're going to have the shaded region outside here that we need. Well, looking at the triangle, what do we know? We know the 60 side, this is equal to x root 3. So the 12 is equal to x root 3 divided by root 3 ends up equaling 12 root 3 over 3, which is 4 root 3. So that's the 30 side, which is over here. So the radius is 4 root 3. Now we can find, because it tells you never use the hypotenuse, so we can find the area of the triangle. So the area of the triangle is equal to 1/2. The base will be 12. The height will be 4 root 3. Multiply that all together, um, and you end up with 24 root 3 units squared. But wait a second, there's two of them. There's one triangle here and one triangle there. So then now we're going to take the answer, multiply it by 2, so that the area of both triangles is 48 root 3 units squared. We said we want to remove the sectors, so I'm just going to remove this whole thing at one time, which to me I'm going to call a sector of 120 over 360 times pi times the radius of 4 root 3 squared. But we knew when we multiplied this, this ends up being 48 pi times 1/3, giving me 16 pi. And now we can put it together. Take the triangle, subtract the sector, units squared. Hope you enjoyed this lesson on 11.6. Have a good evening, and we'll see you tomorrow. Ta-ta for now.